Swayam Prabha. Digital India. Educated India.
Hello everyone. In the previous class, we discussed about the physical interpretation of Moore-Coulomb failure criterion, and then we learnt about the Coulomb-Navier failure criterion. Today, we will learn something which is interesting, which is the concept of instantaneous C and phi. And this is also called as Balmer's approach because it was given by a person named Balmer. This is interesting in the sense that when you use the Moore-Coulomb criterion, and for that the parameters are C and phi, and you have seen that the Moore-Coulomb failure envelope is linear. In the case of the rocks, the failure envelope may not be linear. It is going to be non-linear. Now, is there any way that we can find out the equivalent linear parameters for that non-linear relationship? So, this Balmer's approach gives us the answer towards this question. Let us see how. So, it was given by Balmer in 1952. As per the Moore's failure theory, we have seen that the shear stress at the failure is a function of the normal stress at the plane of failure, or sigma 1 is some function of sigma 3. Now, this functional relationship can be linear or it can be non-linear. Moore-Coulomb criterion is represented by a straight line which is given by this equation, tau f equal to c plus sigma tan phi. We conduct the triaxial tests and we fit the data to this equation, and empirically we try to obtain these two parameters C and phi. Now, for non-linear relationship, can we find out something similar to this C and phi as it was there in case of the linear or the straight line criteria? Yes, we can do that, and that is called as instantaneous C and phi. The question is how to obtain. So, to start with, one needs to keep in mind that this expression or the functional relationship is valid only at the failure, not before, not after. So, take a look at this figure now. We have the relationship between tau and sigma, and the tangent to the Moore circle, which is this, tangent to this at the failure point, which is represented by this point B, is given by this straight line portion. But then when I conduct few more tests at different values of sigma 3, I see that the actual failure criterion is not this linear one, but it is this one which is represented by red color curve here. The question is, this C and this angle phi is defined for this linear curve or the straight line. Can we find out something equivalent for this failure criteria which is non-linear? So, the process of finding this instantaneous C and phi we are going to learn here. So, you consider the triangle ABC here in this figure. So, this ordinate is tau f corresponding to this point C up to point C from the origin. This is sigma n. This is the center of the circle A, point A, whose distance from the origin O is sigma 1 plus sigma 3 upon 2. This is how we draw the Mohr stress circle. So, when we consider this triangle ABC, we can write sigma 1 minus sigma 3 upon 2 whole square is equal to tau f square plus sigma 1 plus sigma 3 upon 2 minus sigma n whole square. Right? So, what I have done is this distance AB square is equal to BC square plus AC square. That simple relationship I have written here. Now, this is going to give me the functional relationship, which is sigma 1 is equal to some function of sigma 3. Now, differentiate this equation partially with respect to sigma 3. What we are going to get, see, this is going to be 2 sigma 1 minus sigma 3 upon 2 and half del sigma 1 del sigma 3 minus 1, because this is tau f square. So, this is no sigma 3 term is there. So, this is going to be equal to 0 plus 2 sigma 1 plus sigma 3 upon 2 minus sigma n multiplied by half del sigma 1 del sigma 3 plus 1 minus 0. Okay, so this is what that we are going to get the expression when we differentiate this equation partially with respect to sigma 3. Now, let us try to simplify this further. So, we are going to get sigma 1 minus sigma 3 upon 2 into del sigma 1 del sigma 3 minus 1. That would be equal to sigma 1 plus sigma 3 upon 2 minus sigma n multiplied by del sigma 1 del sigma 3 plus 1. Or simplify this further, sigma 1 plus sigma 3 upon 2 minus sigma n will be given by sigma 1 minus sigma 3 upon 2 del sigma 1 del sigma 3 minus 1. This whole thing divided by this quantity del sigma 1 del sigma 3 plus 1. This is what that we are going to get. Or sigma n can be written as sigma 1 plus sigma 3 upon 2 minus this whole quantity. So, what I am doing here is I am taking this here and this quantity here, and what we are going to get is sigma 1 minus sigma 3 upon 2 del sigma 1 del sigma 3 minus 1 divided by del sigma 1 del sigma 3 plus 1. That is how we are going to get this. Now, further simplify this. Sigma n is going to be, so what I will do is 2 del sigma 1 del sigma 3 plus 1, and here we will have sigma 1 plus sigma 3, then del sigma 1 del sigma 3 plus 1 minus sigma 1 minus sigma 3 del sigma 1 del sigma 3 minus 1. Further, open these brackets and try to simplify that. So, sigma 1 del sigma 1 del sigma 3 plus sigma 1 plus sigma 3 del sigma 1 del sigma 3 plus sigma 3 minus sigma 1 del sigma 1 del sigma 3, then this minus minus will become plus. So, this will be plus sigma 1 and plus sigma 3 del sigma 1 del sigma 3, and then minus minus plus and 1 minus, so that will make it minus sigma 3. This whole thing divided by 2 del sigma 1 del sigma 3 plus 1. Now see what all terms can get cancelled out. So you see this term and this term will go, then this sigma 3 also will go from here. So ultimately what we are going to get here as sigma n is equal to sigma 1 plus sigma 3 del sigma 1 del sigma 3 divided by del sigma 1 del sigma 3 plus 1. So this is what that we are going to get. We can further play with the terms in order to get a better form of this equation in this way, that is, I add sigma 3 and also I subtract sigma 3 from this expression in this manner, sigma 3 plus 1 minus sigma 3. So see, this is going to be sigma 3 plus I will have sigma 1 plus sigma 3 del sigma 1 del sigma 3 minus sigma 3 del sigma 1 del sigma 3 and minus sigma 3, this divided by del sigma 1 del sigma 3 plus 1. Now this term will get cancelled, and what you are going to get from here is sigma n is equal to sigma 3 plus sigma 1 minus sigma 3 divided by del sigma 1 del sigma 3 plus 1. Now I substitute this in the equation which we had earlier. You remember in triangle ABC we wrote sigma 1 minus sigma 3 upon 2 whole square is equal to tau f square plus sigma 1 plus sigma 3 upon 2 minus sigma n whole square. So just substitute this expression of sigma n in this equation. What we are going to get is tau f square is going to be equal to sigma 1 minus sigma 3 upon 2 whole square minus sigma 1 plus sigma 3 upon 2 and minus sigma 3 minus sigma 1 minus sigma 3 upon del sigma 1 del sigma 3 plus 1 and whole square of the whole thing. So further simplify this equation. What we are going to get is tau f square is sigma 1 minus sigma 3 whole square minus sigma 1 minus sigma 3 upon 2 minus sigma 1 minus sigma 3 upon del sigma 1 del sigma 3 plus 1 and the whole square of this. So, you can write it further. You take out this sigma 1 minus sigma 3 whole square as the common from the whole of this expression, and you are going to get is half whole square minus half minus 1 upon del sigma 1 del sigma 3 plus 1, this whole square. Now this is kind of a square minus b square expression. So you can have a minus b into a plus b. So see, this is what that I am going to do. So the first one you will have half plus this half minus 1 upon del sigma 1 del sigma 3 plus 1. That's the first term, and the second term is going to be half minus half, and this minus minus will become plus. So this will be del sigma 1 del sigma 3 plus 1. So this and this will go. Finally, what you will get here is, just solve this. So this is going to be equal to 1. So 1 minus this whole quantity, you just solve it, and this is what that you are going to get. This is square, and del sigma 1 del sigma 3, this divided by del sigma 1 del sigma 3 plus 1 whole square. This is the expression which we are going to get, and if you take the square root on both the sides, what you are going to get is tau f equal to sigma 1 minus sigma 3 divided by del sigma 1 del sigma 3 plus 1 into square root of del sigma 1 del sigma 3. So this is going to be the expression for the tau f. So earlier we got the expression for sigma n in this manner, and now we got the expression for this tau f. Now again take a look at this triangle ABC. So in triangle ABC, what is that we are going to have? See, this angle is 2 theta. So this angle is going to be 180 minus 2 theta. So in this triangle, what we are going to get is tan of 180 minus 2 theta is going to be equal to BC upon AC, tan of this angle. So this BC is what? Tau f, which is this BC, and AC is what? Is this distance minus sigma n. So this is what I am going to write here, minus sigma n. Now you have got the expression for tau f, and you have got the expression for sigma n. So we just substitute in this expression, and you all know that tan of 180 minus 2 theta is going to be minus tan of 2 theta. This is going to be equal to sigma 1 minus sigma 3 upon del sigma 1 del sigma 3 plus 1 square root of del sigma 1 del sigma 3. This is what is your tau f, and this whole thing multiplied by 1 upon this quantity. So I will write it here, 1 upon, this is 1 upon sigma 1 plus sigma 3 upon 2 minus sigma 3 minus sigma 1 minus sigma 3 divided by del sigma 1 del sigma 3 plus 1. It is going to be this quantity because sigma n we obtained that is given by this expression. So now we further simplify the earlier expression, so which is going to be minus tan of 2 theta is equal to sigma 1 minus sigma 3 divided by del sigma 1 del sigma 3 plus 1 into square root of del sigma 1 del sigma 3 and multiplied by 1 upon sigma 1 minus sigma 3 and half minus 1 upon del sigma 1 del sigma 3 plus 1. So we are going to get this expression. So further you solve it. So what will happen? Your this sigma 1 minus sigma 3 will cancel with this, and if you further simplify this, what you are going to get is 1 upon del sigma 1 del sigma 3 plus 1 into square root of del sigma 1 del sigma 3, and this is 2 del sigma 1 del sigma 3 plus 1. This divided by we will have del sigma 1 del sigma 3 plus 1 minus 2. So you see here this and this also will get cancelled. So ultimately we are going to get a very simple expression which is minus tan of 2 theta is equal to 2 upon del sigma 1 del sigma 3 minus 1 into square root of del sigma 1 del sigma 3. This is what that we are going to have now. You all know that the tan 2 theta can be written in this form as 2 tan of theta divided by 1 minus tan square theta. So if you compare this equation with what we had, so in this case we had tan of 2 theta is equal to 2 square root of del sigma 1 del sigma 3 divided by 1 minus square root of del sigma 1 del sigma 3 whole square. Compare this and this, what you are going to get is theta will be equal to tan inverse square root of del sigma 1 del sigma 3. So this is how we are going to obtain the expression for theta in terms of this derivative which is del sigma 1 del sigma 3. Take a look at this figure again, because still we need to find out C and phi corresponding to this failure criterion which is non-linear. So if you take a look at this figure and concentrate on the triangle ABC once again, this angle is phi, you see. So and this angle is 90 degree. This angle is going to be 180 minus 2 theta. Now since this angle is phi, simple trigonometry would say that this angle is also equal to phi. So in triangle ABC we can write 90 plus 180 minus 2 theta plus phi, this is equal to 180. This will get cancelled out, and what you will get from here is phi is equal to 2 theta minus 90. Now earlier we already have obtained the expression for theta. So from here we can get phi. Once we know this phi, we have the expression like tau f equal to c plus sigma n tan of phi. What all things are known here? What all that we have obtained here? Following the procedure which was given by Balmer, we already have obtained tau f, we have sigma n, here we obtained phi. So the only unknown in this equation is going to be c. So the only unknown is c in this equation. So we just substitute all these three values and one can get the value of c in this case. So you see that how beautifully we could get the value of c and phi for the criterion which is not represented by a straight line. Now this shear strength characteristic, which is called as instantaneous c and phi, it will represent the characteristic of the rock as same as it would have been if this was following a straight line failure criterion. So what exactly we have tried to do in order to obtain this instantaneous c and phi is, if instead of a straight line fit to the failure criterion, if we have a non-linear failure criterion, then we can find out the equivalent values of c and phi for this non-linear failure criterion as it was there in case of the Mohr Coulomb failure criterion. But we cannot call it as the Mohr Coulomb shear strength parameters, therefore we are calling these as the instantaneous c and phi. This is the procedure which you need to follow in order to get this c and phi. So let us summarize this. In the beginning, you have a non-linear relationship between sigma 1 and sigma 3 or between tau and sigma. That relationship you have to partially differentiate with respect to sigma 3, then follow this procedure, find out its derivative, etc. You have already derived the expression for tau f and sigma n. Follow this procedure and you can obtain the value of instantaneous c and phi. So this is what that I wanted to discuss with you in today's class. In the next class, we will learn about other failure criterion which are empirical failure criterion, and I have already mentioned in some of the earlier classes that when we talk about the empirical relationships, they are derived on the basis of the experimental data. So we have to carry out the regression analysis on that experimental data in order to fit an appropriate model which we are calling as a failure criterion or any equation to that experimental data. So we are going to learn some concepts related to this regression analysis, and then we will learn few aspects related to the empirical criterion, followed by the discussion on one empirical criterion, that is Hook and Brown criterion. Thank you very much.